We're going to talk about electric circuits, but before we talk about that, we're going to spend some time talking about a water circuit analogy. Why? Well, because most of what happens in an electrical circuit is hidden to our senses. Now, if we have a motor hooked up to the circuit or a light bulb hooked up to the circuit, we can see the motor turning. We might hear it turning. We can see the light bulb. We can see the heat. Well, we can see the light. And if we put our hands close to it, we might feel the heat. But generally, what's going on in the wires and inside of the battery is completely hidden to our senses. So in order for us to have a more intuitive feel about what's going on in an electrical circuit, I want to introduce you to this water circuit because there are many excellent parallels to the way a water circuit behaves and an electric circuit behaves. So here is our water circuit. It has an upper tank, which currently now is full of water, and there's a little valve there that's closed so the water can't fall. There is a lower tank that is at a lower level, and we're going to just not arbitrary. Well, it's not arbitrary, but we're just going to say that that's H equals 0 because that's the lowest our water is going to go. Recall that from our unit on mechanical energy. And this is, so that means this is at some HH, and so we have our MGH here, and we have gravitational potential energy is 0 here. And this water is going to fall down, and as it does so, it's going to do work on our water wheel, using up that energy to spin the water wheel, which if you do work on something, it will then have the ability to do work, raising this load. Okay, so whenever we're thinking about energy, we want to define our system. Our system is the water itself, and because we're relying on gravitational potential energy, we need to throw in the entire Earth because it's the source of gravity. Okay, let's get our water wheel going. Okay, so now we open the valve and water is flowing spontaneously. And of course, that's common sense. We don't need to force the water down. It's going to flow spontaneously from a higher elevation to a lower elevation. And what we want to think about it is it's going to flow spontaneously from a region of higher gravitational potential energy to a region where there's lower gravitational potential energy. And we don't have to do anything to do that, okay? It's already set up. That's going to happen spontaneously. And as that water falls, it's going to basically transfer that energy to the water wheel. And what we're seeing is that energy is leaving our water-earth system because our water-earth system is doing work on the water wheel. But oh look, now all the water, it's also turned gray, but that doesn't matter. All the water is out of the high tank. It's all down at in the lower tank, which is at 0 gravitational potential energy. So right now we're saying, oh my gosh, there's no more energy in our Earth water system, so it can't do any more work on the wheel, so everything stops. The end. But of course we know that's not the end because we're going to do something that will allow this thing to achieve a steady state scenario. And that is, we're going to add you as an energy source and a pump, and you're going to continuously do work on that pump, and it is going to force water back to, it's going to basically take it from that lowest gravitational potential energy and deposit it back onto the upper tank where it has more gravitational potential energy. In other words, you're going to do work, and that work will cause a potential energy difference, a positive potential energy difference. So you're giving that water the energy it needs to continue to do work on the water wheel. And so this is what we see is in a steady state water circuit is you continually do work on the pump. Pump does work on the water, raising it up against gravity. And then in a steady state, that water is going to flow, falling down spontaneously, and in so doing work on the water wheel. This is the part where you do the energy comes in here, and the energy leaves spontaneously over here. This is a complete water circuit in a steady state. That's what I just said. Okay, now we're switching over to an electric circuit. Okay, this is kind of wordy, but let's look at the highlighted terms here. Basically, we have current. Well, we could think of the water moving through a water circuit as the current, the flow rate. But basically, we have electrons are going to flow through the circuit because of a difference in potential energy between the two electrodes. Okay, let's get down here to the... Here it is right here. Electrons flow spontaneously from zinc to copper, just like water flowing spontaneously downhill, which can be made to do work by forcing a water wheel. The flow of electrons from a higher potential energy to a lower one can also be harnessed to perform work. Hence the water wheel water circuit analogy. And here we have them side by side. We've already talked about our water circuit. We see water will move spontaneously from a region of higher gravitational potential energy to a region of lower gravitational potential energy. And in so doing, as it flows, it can do work on the external environment. Well, that's very similar to what goes on in an electric circuit. It turns out, because of the atomic structure of matter, that the zinc electrons, the valence zinc electrons, those mobile electrons, we're just going to use the term mobile charge now, they basically have more electric potential energy than the valence electrons of copper atoms do. And so what we're going to see is this spontaneous flow of those mobile charge from a region of high electric potential energy down to a region of low electric potential energy. And nothing is required to make that happen. That's going to happen spontaneously on its own. And as those mobile charge, we'll just say, flow from higher potential to lower potential, they will do work on anything that's essentially in the way. So there could be a light bulb here, a motor, speakers, anything that, and we're just going to focus mostly on things like light bulbs, motors, etc. But that flowing mobile charge will do work as it flows to the region of lower potential. What the heck? Okay, well that's what I just said. So if you really want to read that, you can pause the video. Okay, and just like to keep the water circuit going, water will not flow spontaneously forever from high to low potential because you're going to run out of water. You're going to need a way to take the water that's at low potential and move it to the high tank where it will have higher potential. And that's where the energy in part of the circuit comes. You or a horse or a squirrel or your best friend, somebody somewhere is going to have to put energy into the system to operate the pump that will force the water to higher potential. This will not happen spontaneously. And guess what? In a battery, and we're only going to talk about battery powered circuits for now. There's a similar process. There are other processes by which this happens, but with a battery it happens exactly like this. Okay, so those mobile charge have fallen spontaneously from high potential to low potential. Now you have to get those electrons, the mobile charge, where they want to be, from where they want to be to where they don't really want to be. And so that means something has to do work on that charge, raising them from low potential to high potential. And of course, this is all hidden inside of the battery. This is a chemical process. We're taking chemical energy, and the means are these chemical reactions, and that's how the chemical energy via these chemical reactions ends up pushing the charge. So I want you to think of a battery. The chemistry in the battery is literally like a charge pump. Well, I don't think literally, and by analogy we can think of it as a charge pump in much the way that this is a water pump. Now you have to do work on the water pump. With a battery, the energy is already inside of the battery in the form of chemical potential energy. Okay, So what we've done is a little bit abstract here, but I mean, what's everything inside of this dashed line is going on inside of the battery, hidden from our view and our other senses. So we have the chemical energy, we have the reactants, but basically what's happening is that the mobile charge is flowing spontaneously from zinc down to the copper, and in so doing will do work on anything that's in the circuit. So for example, here we have our light bulb. So energy is coming out of our light bulb as those mobile charge are flowing from high potential down to lower potential. And just like with our water circuit analogy, we need a way of getting that mobile charge back up to high potential, and this is where the chemistry comes in. And this is what's going on inside of the battery, completely hidden from our view. So whenever you want to think about what's going on in an electrical circuit, come back to that water circuit analogy.